There have been several reported incidents of shocks or electrocutions involving water meters. In 2021, a water meter reader in California was electrocuted while removing a meter from a residence. In 2018, a plumber in Oregon was shocked while disconnecting a water meter. In 2017, a homeowner in Colorado suffered an electric shock while replacing a water meter. The most common cause of electrical hazards involving water meters is contact with live wires or stray voltage. Current can travel through the water pipes and meter due to problems with grounding or electrical wiring in the home. Faulty wiring or incorrect wiring or loose connections in the meter box can create electrical hazards. Water companies have established practices and procedures to reduce the risk of electrical hazards during meter maintenance, removal, installation, and servicing. Water pipes should be properly grounded to prevent voltage from building up. Only insulated tools should be used when working on water meters. Rubber gloves, safety glasses, and work boots should be worn at all times. Meters should be tested for electrical integrity before and after servicing. Service lines should be isolated before working on meters to prevent the flow of electricity. Water company employees should receive training on electrical safety and proper meter handling. Meter work should be scheduled outside of peak usage hours to minimize the potential for electrical hazards. Regular inspections and maintenance of meters and associated electrical components can help prevent electrical hazards. Firstly, water companies prioritize grounding. This involves ensuring that water pipes are correctly connected to a grounding system. This provides a path for stray electrical currents to safely return to the source, preventing them from energizing the water meter or pipes. Secondly, the use of insulated tools is crucial. Workers are equipped with tools that have non-conductive handles and coatings. This prevents electricity from flowing through the worker's body if they come into contact with a live wire. Thirdly, personal protective equipment, or PPE, is mandatory. This typically includes rubber gloves, which provide insulation against electrical shock, safety glasses to protect the eyes from sparks or debris, and work boots with non-conductive soles. Fourthly, meter testing is performed regularly. Before and after any servicing, water meters are tested for electrical integrity. This involves checking for any stray voltage or current that may be present in the meter or pipes. Fifthly, isolation procedures are implemented. Before working on a meter, service lines are isolated to prevent the flow of electricity. This may involve shutting off the power supply to the area or using insulating barriers to block the flow of current. Sixthly, comprehensive training programs are conducted. Water company employees receive thorough training on electrical safety practices, proper meter handling techniques, and the identification of potential hazards. Seventhly, scheduling considerations are taken into account. Meter work is ideally scheduled outside of peak usage hours to minimize the potential for electrical hazards. This reduces the likelihood of encountering high voltage or current levels. Eighthly, regular inspections and maintenance are performed. Routine inspections and maintenance of meters and associated electrical components help to identify and address potential electrical hazards before they can cause harm. Additional safety measures that homeowners can take include firstly, shutting off the water supply before beginning any work. Secondly, calling a licensed electrician if there are any signs of electrical problems. Thirdly, avoiding contact with any exposed wires or components. If an electrical shock occurs, seek medical attention immediately. Stray voltage refers to unwanted electrical potential that can exist in unexpected places. It's a common concern related to water meter safety. This voltage, even if low, can pose a shock hazard if a person comes into contact with both the energized object and a grounded surface. There are several reasons why stray voltage might be present. Firstly, faulty wiring. Problems within a building's electrical system, such as damaged insulation or loose connections, can cause current to leak into nearby metallic objects, including water pipes and meters. Secondly, improper grounding. A properly installed grounding system provides a safe path for electrical current to return to its source in the event of a fault. If the grounding system is inadequate or improperly connected, stray voltage can occur. Thirdly, shared neutrals. In some cases, multiple circuits may share a single neutral wire. If one of these circuits has a fault, the stray current can travel through the neutral wire and affect other circuits. Fourthly, external sources. Stray voltage can also originate from sources outside the building, such as nearby power lines or electrical equipment. The voltage can then be induced into the water pipes or other metallic objects. When stray voltage is suspected, it's crucial to take appropriate safety measures. Firstly, avoid contact with the affected object. Do not touch the water meter, pipes, or any other metallic objects that may be energized. Secondly, call a qualified electrician. A licensed electrician can diagnose and repair the source of the stray voltage. They will use specialized equipment to test the voltage levels and identify any faults in the electrical system. Thirdly, ensure proper grounding. Make sure that the building's electrical system is properly grounded according to local electrical codes. This will help to minimize the risk of stray voltage and provide a safe path for current to flow in the event of a fault. Fourthly, inspect wiring. Regularly inspect the wiring in the building for any signs of damage or loose connections. Repair any issues promptly to prevent stray voltage from occurring. Fifthly, consider a ground fault circuit interrupter, or GFCI. GFCIs are designed to detect even small amounts of current leakage and quickly shut off the power. They can be installed in areas where there is a risk of stray voltage, such as near water meters or plumbing fixtures. Water companies follow specific procedures to minimize the risk of electrical shock during meter maintenance, removal, and installation. These procedures often involve, firstly, identifying potential hazards. Before beginning any work, water company employees will assess the area for any potential electrical hazards, such as exposed wires or signs of stray voltage. Secondly, wearing appropriate personal protective equipment, or PPE. This includes rubber gloves, safety glasses, and work boots with non-conductive soles. Thirdly, using insulated tools. All tools used for working on water meters should be properly insulated to prevent electrical shock. Fourthly, isolating the water supply. Before disconnecting a water meter, the water supply should be shut off to prevent water from coming into contact with electrical components. Fifthly, testing for stray voltage. Before touching the water meter, it should be tested for stray voltage using a specialized meter. If stray voltage is detected, the power supply should be shut off before proceeding with any work. Sixthly, grounding the water meter. After disconnecting the water meter, it should be properly grounded to prevent the buildup of static electricity. Seventhly, follow and lockout tagout procedures. If the power supply needs to be shut off, lockout tagout procedures should be followed to ensure that the power cannot be accidentally turned back on while work is being performed. Regular maintenance of water meters and associated electrical components is essential for preventing electrical hazards. This maintenance should include, firstly, inspecting for damage. Regularly inspect the water meter, wiring, and other components for any signs of damage such as cracks, corrosion, or loose connections. Secondly, testing for stray voltage. Periodically test the water meter for stray voltage to ensure that it is properly grounded. Thirdly, tightening connections. Ensure that all electrical connections are tight and secure to prevent loose connections from causing electrical hazards. Fourthly, replacing damaged components. Replace any damaged components promptly to prevent electrical shock. Fifthly, keeping the area clean and dry. Keep the area around the water meter clean and dry to prevent water from coming into contact with electrical components. Sixthly, documenting maintenance. Keep a record of all maintenance performed on the water meter and associated electrical components. In summary, electrical hazards associated with water meters can be serious, but they can be effectively managed through a combination of proper procedures, safety measures, and regular maintenance. For water companies, grounding, insulated tools, personal protective equipment, meter testing, isolation, training, avoiding peak times, and inspection and maintenance are critical. For homeowners, shutting off the water supply, calling a licensed electrician for electrical problems, avoiding contact with exposed wires, and seeking immediate medical attention in case of shock are vital. Stray voltage can be caused by faulty wiring, improper grounding, shared neutrals, or external sources. When suspected, avoid contact, call an electrician, ensure proper grounding, inspect wiring, and consider a GSCI. Water companies follow procedures to identify hazards, use PPE, use insulated tools, isolate the water supply, test for stray voltage, ground the meter, and follow lockout-tagout procedures. Regular maintenance includes inspecting for damage, testing for stray voltage, tightening connections, replacing damaged components, keeping the area clean and dry, and documenting maintenance. By diligently following these guidelines, the risks associated with water meters can be significantly reduced, ensuring the safety of both water company employees and homeowners.